This section is about 2.5 polygons. We're going to take some of the things that we've learned throughout this unit and apply them when we talk about polygons. All right, take a moment and think about what you think a polygon is. What have you learned in the past? We know that these are convex polygons, these are concave, and then these are not polygons. But why? Take a moment, write in your notes, and then we'll come back. Okay, so when we talk about a polygon, I should be able to have 2 points and be able to draw a line between them. Okay, if those 2 points and a line stay inside the shape the entire time, that is called a convex polygon. When we talk about a concave, I can draw 2 points and connect them, and I go outside the shape. Think about it in terms of a cave. You go inside to have that cave. But notice when we talk about polygons, look at the edges. What do you notice over here? We have some curves. It bends and goes all over the place, or it's not even closed. That's why these aren't polygons. Here's your definition. A polygon is a closed figure created by line segments that intersect only at their endpoints. So that means having something like this is not a polygon. They intersect not only at the endpoints, but also right here in the middle. So that's why this is not a polygon. So we have some types of polygons here, okay, with some names. So when we think about these things, okay, we have regular, equilateral, and equiangular. Okay? Equilateral means that all sides are the same. So all 4 of my sides here of this shape are exactly the same length. That's why it's equilateral, equal lengths. When I talk about things like this second one, where all of the angles are the same, that's called equiangular. All of the angles are equal. Last but not least, if it's both equilateral and equiangular, it's a regular polygon. So remember, a regular polygon is both equilateral and equiangular, if I can spell it right. Okay? Now let's talk about angles of a polygon. So I've drawn a triangle, a quadrilateral, a pentagon, and a hexagon. Now first I want you to think about how many sides they have. So go ahead and fill in this top row here with how many sides they have. Okay, we know that the number of sides in the top, we have 3, then 4, then 5, and then 6. When we talk about the number of diagonals, okay, I want to know from one vertex, how many diagonals can I draw to a vertex across the shape? So that means if I start here, I can't draw a line there or there. That means that I'm going to have 0 diagonals for a triangle. If I start here, I can't go up or to the right, but I can go to the left, the top right, excuse me. So that gives me 1 diagonal. Over here, I can go across and diagonal. That gives me 2, and then this one would give me 1, 2, 3. Take a moment and figure out how many triangles you can see in each one of these shapes now that the diagonals have been drawn in. So we only have 1 triangle, our initial triangle. Here we have 2. After that I see 1, 2, 3, and then 4. Now we want to figure out how many degrees are in the whole shape. We know that a triangle from yesterday has 180 degrees. When we look at the quadrilateral, I have 2 triangles, so that means I have 2 times 180, or 360 degrees. The next one, I have 3 triangles. 3 times 180 gives me 540. Last but not least, this last one, I have 4 times 180 because I have 4 triangles. So that gives me 720 degrees. So if I think about this, the interior sum of the polygons, all right, I notice, look, if I take this and I see that I have, sorry about that. If I have this 2 here, and I had 4 sides, I had 1 and I had 3 sides. I have 3 and 5, 4 and 6. Do you notice a pattern? Well, we are taking the number of sides and subtracting 2 and then multiplying that by 180. If I want for a regular or an equiangular polygon, and I want to know just one angle, I can do that, right? I can take the total sum, so n minus 2 times 180, and if I divide it by the number of sides, right, because I have 3 angles and 3 sides, 4 angles and 4 sides, that's going to give me one measure of one of the angles. So we can figure out how big this angle is here if we wanted to. So go ahead and make sure that those are all in your notes, especially these formulas here. Okay, why don't you take a moment, pause the video, and find one angle of a regular dodecagon. Okay, and that's a 12-sided polygon. Okay, so I know that the formula to find one angle is the number of sides minus 2 times 180 all over the number of sides. So if I have 12 sides, n is 12. So 12 times 2, or 12 minus 2, excuse me, times 180 all over 12. If my math is right, remember this is the sum of all angles, and this is the number of sides, and that gives measure of one angle. Okay, so if I know if my math is right, that gives me 150. So that tells me that each interior angle is 150 degrees. All right, last but not least, let's talk about some exterior angles. The exterior angles in this case are the ones that have primes. So 1 prime, 2 prime, 3 prime, 4 prime, n prime, etc. So at each angle, the exterior angle and the interior angle make what? What do you think? They make a linear pair. So now I want to figure out how many degrees that the sum of the exterior angles make up. Okay, now I know that I can have the interior angles plus the exterior angles. And that's going to give me the number of angles that I have times 180, right? Because a linear pair equals 180. And if I have an n-gon, right? So if I have n sides, I can look, okay, 1, 2, 3, 4, n. I have n pairs of 180. And then I take away the interior angle measures. So that, we know that from before, that's the n minus 2 times 180, right? Because that's going to give me the sum of all of these guys in here. And then that's going to leave me with the exterior angles. So that leaves me with the exterior angles. So that gives me 180n. Remember this negative here. Okay, so I have minus 180n plus 360. And that leaves me with my exterior angles. Now if you notice here, 180n minus 180n goes away. So my exterior angles, no matter what, will always sum to 360 degrees. No matter how many sides or how many anything, the sum of your exterior angles will always equal 360. Now for regular and equiangular polygons, to find one exterior angle, we take the 360, which is the sum of the exterior angles, and we divide it by n, which is the number of sides. And when you do that, so for example, if you have a pentagon, you would do 360 divided by 5, and that would give you one measure of one exterior angle. So that could be this angle out here, for example.